In today's project, we are going to combine electrical engineering and mechanical engineering to build a crazy robot car. This project will be a little car that moves quickly across the floor when you turn it on. Let's make sure that we have all of our materials ready so that we can start building our crazy robot car.
Now that we know what we're making, let's go over our materials. For this project, we're going to need 2 AA batteries, 1 AA battery holder, 1 paper straw, 2 3-volt motors, 1 2mm metal axle rod, 4 plastic wheels, 1 6-inch copper tape, 2 2-inch by 6-inch Lego plates, 1 10 by 6 Lego plate, and 4 double-sided tape squares. Once you have all of your materials, we're ready to start building our crazy robot car.
To start our project, we will be using the Lego pieces to create the body of our car. The large gray Lego piece will make up the majority of the body, and the smaller pieces can be used to add some design to the car. You can make the front wheels lifted or just the back wheels. You can even lift both ends to keep the car balanced. And here's how I usually like to create my design. With the front and back of the car. But encourage your students to create their own design, and next we will attach the battery holder to our base. Grab your battery holder and ensure you're practicing electrical safety by ensuring the battery holder is off and that you have not yet inserted your batteries. We will do that at the end of our project. Attach one side of a double-sided square to the back of your battery holder, the side without a switch. Peel off the backing of the double-sided square and attach that side to the Lego base that we created earlier. You should still be able to easily switch the battery holder on and off. Next, we're going to use copper tape to connect the battery holder wires to the wires on the 2 motors. This is the most difficult portion of the project, so go through these steps slowly. It can also be helpful to label or memorize one of the motors as 1 and one as 2, although it doesn't matter which is which. We'll start by taking the black wire of the battery holder and the black wire of motor 1 and the red wire from motor 2. We're going to attach these wires using copper tape. Everyone will find their own technique to make this connection, and you should encourage your students to do the same. The technique that works the best for me is to first get a little bit, or peel off about 1 inch of copper tape, peel off the backing about halfway. We're going to attach first the 2 wires from our motors. So it should be 1 black wire into the copper tape and 1 red wire from the other motor directly next to it. Ensure that your students are connecting 2 different motors. Sometimes they confuse and connect 2 wires from the same motor. You can fold this copper tape over slightly, leaving a lot of copper tape left over. Then we will grab the wire from our battery holder and put that nearby those 2 connections. Peel off the remaining copper tape and wrap it around those wires. Pinching tight at the end to make sure that everything is secure. And again, we have black wire from our battery holder, black wire from motor 1, red wire from motor 2. Once you've made your first connection, take the remaining 3 wires and connect them the same way you did with the first 3. If you connected the correct wires the first time, the remaining 3 should be the red wire from the battery holder, the red wire from motor 1, and the black wire from motor 2. And you should connect these 3 with the same technique that was successful the first time. If you're having trouble peeling the copper tape, you can try to get a fingernail underneath or use the end of one of the motor wires to peel off the end of the copper tape. I accidentally ripped off a bit of copper tape, but that can just be wrapped around to keep our wires secure. Now that all of your wires are connected and you're sure that they won't come loose, we're going to carefully attach one wheel to the pointy end of each motor. So we'll grab two wheels. You'll notice that there's a little hole on the inside of your wheel, and the little pointy end of your motor will fit into that hole. It might be difficult at first, but just gently apply pressure to the motor and wheel, squeezing them together, and they will become attached. Do this with both wheels and motors. You should also advise your students to be careful with these fragile wire connections while attaching the wheels. Sometimes if they apply pressure on the end of the motor, these might snap off. Now we're going to use our double-sided squares to attach the motors to the Lego base. We're going to peel off one square, and before we attach it, we're going to cut it in half so that it will correctly fit with the motors. Now you can attach each half to the bottom of the motor to attach them to our Lego base. You want to attach them to the side of the motor without the wires. So we're going to attach it like this. And then we will attach them to our Lego base on one of the sides, facing opposite directions, with one facing on the left and one facing on the right. So I'll peel off the tape and do that. It should look like this. Congrats! We are done with the wires and now only have a couple of steps left before we finish. Now we're going to take our straw and we're going to cut a section that is the same width as our Lego base. Take that small section of straw and insert your metal rod through the straw. Next, we're going to take our last two wheels and insert one wheel at each end of our metal rod. If you try to do this one at a time, it may be pretty difficult and you might hurt your hands. Instead, I recommend taking a wheel in each hand and sandwiching them between the metal rod until they are fully attached. So we can put the metal rod in the hole of each of the wheels and sandwich the metal rod in between. If you want to apply more pressure, you can also do it vertically. This way, our wheels can spin freely inside of our straw. Once the wheels are fully attached to the metal rod and straw, use a double-sided square to attach the straw to the opposite end of the Lego base as our motors. I also recommend cutting this square in half to better fit the Lego base and straw. And if you want to make this connection more secure, you could also add more tape on the bottom of the crazy robot car. At this point, you can go ahead and insert your batteries into the battery holder, and after that, your project is complete. So now that you have your completed robot car, it should look something like this, but you may notice the wires are going all over the place. So we're gonna wanna tape these down so that it doesn't interfere with the car moving. Make sure to kind of pull the wires through the motors in the bottom so it doesn't interfere with the car moving. And then another thing to keep in mind is that these two bundles of wire where the copper tape is, you don't want these to touch because then your car might not work. The best way to do this is to take some tape and to tape it on the copper tape. That'll keep the wires together and also make sure that these two copper tape connections don't touch. And I'll just tape these onto the top of the battery pack, while also making sure that I can still access the switch on top. And now that you've got the wires cleaned up, we are ready to test. To test our crazy robot car, simply flip the on switch from the off to the on position, and your car should move on its own. If you notice your car is backwards, you can turn it around, and that can be the new front of the car. If you really want your car to move in a certain direction, you can switch the motor's position, and that will change the direction that the car moves. If your car isn't working at all, it can be one of two key problems. It's either that the copper tape isn't tight enough, a common problem, or that the wheels are hitting something that is preventing them from spinning. The first thing that you can check is your wires, and you can make sure that you have the correct ones attached. After that, you might want to double check the copper tape connections to make sure they're tight. You can pinch them to see if the connection is too loose. Test it by holding your car in the air to see if there's only one wheel moving or if none are moving at all. And if the motors are working, you can check that the wheels on the metal rod are also spinning freely. If they're getting stuck, you can try cutting the straw smaller, or you can try checking for any blocks with wires. Once you check those common problems, your project should be working perfectly. Like with all electrical projects, make sure you do not leave your project running and unattended. You also want to give them a break every now and then because if they're running for a few minutes, the motors tend to get hot. You now have your very own working crazy robot car, but how does it work? Although it was difficult to attach the wires, the way that it works is actually really simple. The electrical energy from the battery holder distributes through the wires evenly to the two motors at the same time, spinning them in opposite directions. They spin in opposite directions so that when they're both in the front of the car moves forward instead of rotating in a circle. This is why we wired them the way that we did. If we connected all of the black wires together and all of the red wires together, the two motors would spin in the same direction, spinning the car in a circle. Now that we know how the project works, some questions that you can ask your students are how they think they can make their car faster. Do you think you can control the direction of the car? What can we add to improve the body and the shape of the car? What would happen if we only had one motor? And what do you think would happen if we had more than two motors?